And I'm going to begin by sharing my screen. Wait. Where is my... Oh, here. Okay. Now I can share. All right. So we're going to begin chapter 20, which is called Redundant Coding. And this is book 20. This is chapter 20 of the book, Fundamentals of Data Visualization by Klaus Wilke. This is the book that we're reading, and I'm going to cover today chapter 20. Okay, so now let me get rid of this. Before, let me just begin the chapter. I put it on the Slack, in our Slack channel. Just remember to sign up for any of the other chapters that we're gonna be reading for the coming weeks. Technically, we only have 4 more meetings and then we're done with the book because we are doing 2 chapters per week. And then that means that we'll be done before the US Thanksgiving. So before the week before November ends. So that's great. We are on the last few chapters. Yeah. So having said that, I'm gonna go to chapter 20 and begin. So this chapter is called Redundant Coding. So we're gonna go through what the author means by that in this chapter, and then go over some of the advice that he gives on when to use this redundant coding. So redundant coding, like I mentioned, is a term coined by Klaus Wilke, and it refers to something that I'm pretty sure we have all encountered, which is using multiple different aesthetic dimensions to convey the same information presented on a graph instead of relying just on color. So what that means is that we usually use color to convey a dimension, let's say sex, for example, if we're looking at males versus females on something, but then instead of just using, let's say, blue and yellow for these to differentiate this dimension or this variable, what we do is we also add another aesthetic to differentiate between the two, in addition to color. So that's why he means redundant coding, because it's the same information presented with different dimensions. And we're going to explain exactly why. So the first part is called Designing Legends with Redundant Coding for Scatter Plots. So what this means is that when we have scatter plots that represent different groups, we usually differ those groups by color, like this example that we have here. So I don't know if you remember, but this is a very common data set used in R. It's one of the data sets that's already that it already comes with base R. So the idea is that you have here 3 different species of iris, which is Iris setosa, Iris virginica, and Iris versicolor. So these are 3 flowers. And what you're doing here is you are mapping on the scatter plot the relationship between the sepal length and the sepal width of each individual, showcase how different they are between these 2 variables. We rely on color to differentiate them, right? To show how different they are. However, sometimes differentiating between 2 groups, in this case, it's going to be virginica and versicolor, because they're so similar, and we used a color that is very similar between them, in this case, it's green and blue, then the differences are not that easy to understand in this graph. And then, so we usually do, well, for example, let's change colors or let's use grayscale, but sometimes that doesn't really work because then the grayscale doesn't make it distinguishable enough. And that's what we mean by using redundant coding, because to represent the differences between these factors, in this case, the different species of iris, we're not just using color, but we're gonna also use the shape symbol to differentiate between them. So we are essentially using two aesthetic dimensions, which is color and the shape symbol, as a way to differentiate species. So that's the redundancy. We should just rely on one aesthetic to do this, but instead, to make things more clear, we go there, because color is not always the solution for these situations. So in this case, if you see here, which is the fixed graph, which is a much better interpretation of the data versus the first one that we had here that says bad. So on this one, what we have is a bit more clear because we switched colors instead of doing blue and green for Virginica and versicolor, which are the ones that are very similar. We switched it to yellow and green, which these are even for people that have color blindness. It's even easier to see the contrast between them. And then in addition, we added a different shape. In this case, we added diamond for Virginica and little squares for versicolor. And Setosa is still with like the little circles. So this is an example, the basic example of redundant coding. Okay, let's go ahead. Another way of using redundant coding is in line graphs. Or in line plots. So here, usually what we do or what we think about is when using another aesthetic other than color is changing the line type. Instead of having a solid line type, we think, oh, well, let's differentiate it using dotted lines and dashed lines. But the problem with that is that if the lines are not straight or curved, if they're like this ones that are like a little bit more broken, then it's not clear. It becomes so cluttered and you cannot differentiate which one is solid, which one is dashed, which one is dotted. So it really doesn't help us at all to use color to differentiate between groups. In this case, what we have here are stock prices between four major tech companies across 1, 2, 3, 4, across 5 years. So we have year on the x-axis and we have stock price on the y-axis. Each color represents a different tech company, right? A different stock. So to fix this problem, instead of relying on changing the line type, what we do is we have to manually reorder. I know how to do that in R. I'm pretty sure you can do that in Python too, or whatever language you're using. But essentially what you do is instead of letting the program, the language that you're using to do this automatically, they are going to rely on alphabetic order usually. So instead of doing that, you put the order of the factors, you change it so that you say which one goes here on the legend, which one goes second, which one goes third, and which one goes fourth. So that, if you take a look at this, matches exactly the order that you have, at least at the end, because at the beginning it's a little bit confusing, but at least at the end, you see that that is the same order that we have with our graphs, with our lines. That exactly is mimicked in our legend. So that helps so much with interpretation, because the person that's reading this graph, the audience, doesn't have to necessarily rely only on color and then just try to match it between the legend and the graph. But it's super easy to read. It's just like in one take, you say, oh, that's the same order. Perfect. So that is, again, redundancy, because you are reordering your legend, which would be one aesthetic, in order to match the colors too. So that again is redundancy, right? You have to work it in two parts. Anyway, then you can also, with this whole redundant coding concept, you can also rely on not having legends because they are adding more noise to your graph that's unnecessary. So for example, when some things are so obvious, you can actually eliminate the legend and just put that label on the graph directly. Because that element is so obvious, then the graphical element represented inside the graph is going to be more helpful than if you put it on a legend. That's going to create more clutter and it's going to create more noise around the graph. And again, the different languages are going to help you do that. The general strategy here is called direct labeling, where what you do is you put exactly the same label that was on the legend, you put it on the graph. You can either put it at the end, you can put it on top. It depends on where your lines are, but they serve as guideposts to the rest of the figure. So in this case, because of the way the lines are and are organized, it makes sense to do this because if our graph looked just like this bit right here, it probably wouldn't make sense. Imagine if you're just doing year 2013 to 2014, this probably wouldn't work. But because they're so separated, I think that that makes sense here. So instead of having a legend here, you have the direct labeling at the end, or you could even put it on top of the line. Other people, what they do is they also put the name, the label, using the same color as your line. So that's another way to differentiate them too, to make it easier for readers to sort of like get the message. I do know of a package in R that what it does is, but it's not, I can show it at the end. You have to use it sparingly and know when to use it. But what they do is they encode the label within the line, kind of like when you're doing like a lasso thing. So it looks super cool, but it only works if you have like straight lines or if you have a curve, something that's not as jagged as these lines, as these lines. Because here, so the idea would be to just not have like this little part right here of line that you see. And instead of having that line, you would have Facebook written there. So it looks super cool, but like I said, I mean, I've only done it in R. So I'll see if I can find you an example at the end. But that's another way of seeing this. Other examples that we have with this is that instead of, like I said, having the legend, you can use here in this line plot the different shades of each color to represent each curve. So if you see, you have for each one of the density plots, you have a darker blue or a darker yellow or a darker green for the outside of the plot, of the density plot, and then inside it's a little lighter. And then you also use the same darker color that you have on the line. You use it to direct label each one of your groups. And in this case, the author decided to put them here on this side, on top of the other one, and on the side of the other one, right? You can actually choose where to put the direct label. Another example, and this one was like, this makes so much sense. I haven't thought of it, but it makes so much sense. So sometimes what we have is gonna be a graph that's gonna have, again, a y-axis. In this case, we have temperatures, environmental temperatures, right, in Lincoln, Nebraska in 2016. So what we have is all the different months from January to December on the y-axis. And on the x-axis, what we would expect to see is temperature. From minus, let's say 20 minus 25 or something like that, all the way up to 100. So that is more or less like the range of temperatures that we would expect to see here, just a regular x-axis. However, what the author is saying is that to eliminate that redundancy, if you have here a legend where you're showcasing the darker the color, the colder it's gonna be, and the lighter the shade, then that means that it's gonna be like hotter. Then why not just do that legend instead of having it separately, which is already conveying temperature, just put it on the x-axis instead of just having temperature on the x-axis and temperature on the legend. Just combine it. The temperature here, what it's showcasing is how much temperature varies each month. So as you can see here in December, I actually lived in Lincoln, Nebraska for a few years, and I can actually tell you that this is so accurate. So December you can have at the end of December super cold temperatures and then way warmer. So that's fall there, right? Like it's at the beginning of winter. It's crazy. So then that's exactly what you're showcasing here, how variable each month is in terms of temperature. So just eliminate the redundancy and just put um, the scale on the x-axis. And I think that's genius. I haven't thought of that. So sometimes it makes sense to add redundancy to the graphs in order to add clarity. And then in other parts, it makes sense to just eliminate that redundancy by combining the legend with the x-axis. And that's it. That's it for this chapter. I don't know if anybody has any comments. Arthur?
Yeah, I was actually, to the extent you've explored, for the last thing with the Lincoln, Nebraskan temperatures, is that something you can do with R? Because that is indeed that's a really cool idea of putting your color scale and embedding it on the axis. I guess I
I've
could I
never
could
done
look
it.
in the repo
Yeah.
for the book, but I was just curious if you'd looked.
I didn't look at the code because I've never done it. And to be honest with you, this is the gem in this chapter, I think. Because the other things are like, yeah, those are kind of like, yeah, I've heard of those. This one, I haven't thought of it. I want to go and explore. If you want, we can open the GitHub and see how it's done. Because to be honest, I've never done this. Like put the scale, the legend on either of the axes. I have never. I have no idea how you do that.
Yeah, me neither. Also, I was in looking at the chapter and hearing you talk, I was thinking also, I mean, granted, this is a little bit going into the chapter 22, I think, but it's
Oh,
sort of like if you could blend tw chapter 20 and chapter 22. I've also found it really nice that if you have a title or a subtitle that says something and mentions the levels, then you can use the color coding in the title. So I think that's using one of Klaus Wilke's packages as well. I can't remember the name, but it's one where you can do markdown specifications of the labels.
oh, okay,
Yeah,
yeah.
I'll drop a link to an example from UNHCR has a nice ggplot2 package, and they demonstrate that in their examples.
That's super cool. Yeah, you're right. 20 and 22 should have been together because essentially it looked like they were talking about the same thing. Yeah. Yeah, so yeah, drop the link on Slack or here on the chat. That'll be great. Yeah. But yeah, the only thing that I didn't cover is how when you how it looks with the different color vision um situations. I don't like to call it deficiency, but yeah, I guess color vision deficiency, how it looks like differently when you select these colors, just as a way to compare that sometimes um, relying on color alone is not enough. So you have to like really reorganize your legend to help your readers understand your information better. That's the only thing that I didn't cover, but I feel like we covered it when we talked about color in the past chapter. All right, you guys, let's move on to chapter 21. Oh, I see you dropped them. Oh, perfect. You dropped them on the chat. Thank you so much, Arthur. Okay, so chapter 21 talks about multi-panel figures. I'm pretty sure we're all familiar with these ones. The idea the ideas that we're gonna be covering here is how to represent large and complex data using multi-panel figures, and then distinguish when to use. There are two types, and we're gonna distinguish when to use each one. So let's begin. So when you are working with large and complex data sets, you have to really start to envision how you're going to represent all of that into one single graph. Sometimes it's not enough to just have one graph. And what you have to do is divide it into multi-panels that consist of multiple figure panels that shows the same subset of the data, or that shows the same data in different subsets, I should say. So this first idea, or this first multi-panel type that we're going to see, it's called small multiples, where what you have is the same type of visualization, let's say line graphs, and this represents different slices of the data in a form of a grid or in a grid layout. However, we also have compound figures, where what you show is, it could be the same data set, or it could be two related data sets, where you are showing different visualizations arranged not necessarily in a grid, but in a composite figure. So in this case, you're going to have a line graph, let's say a bar graph, and then you can also add two other graphs on that same composite figure, right? So you can have one single data set, but you're representing different parts of that data set, or two related data sets that in a way they have to be related, and they have to represent the same key idea. And you're just sort of arranging a Frankenstein, if you will. At least that's how I call them. So we're going to go through each one of them. The key issues to watch out for when combining these panels, it doesn't matter which type of multi-panel figure we're dealing with. So these key issues are the things to watch out for, is axis scaling and consistency across panels, alignment of graphical elements, and maintaining a coherent visual language across panels. Otherwise, your reader is just going to get lost. So let's start with the first type, which is small multiples. So this idea refers to slicing one data set along one or more dimensions, like by year, by class, by group. And then you're going to plot each slice using the same visualization style, but arranging it in a grid. This is also called faceting when we're talking about ggplot2, for example, and R. We do this by doing facet grid or facet wrap. Those are some of the functions that do this. All panels should ideally use the same axis scales and ranges, but if not, the reader may misinterpret differences or be misled. So that's the first thing that we should watch out for. In this example, we can see that we have the passengers on the Titanic, and we organize them in two groups, by the ones that died and survived, and by the class that they traveled in, if there were first, second, or third class. So this is the same data set. We just organized it. We sliced it, like the author says, in different little groups and categories. So the first thing is, we have, for all of them, we're going to have females on the left and males on the right. And that has to be consistent for all the different panels. Our y-axis also has to have the same consistency. It has to go, in this case, it goes from 0 to, let's say, 200, because this is count how many people lived or died and how many people were in different class. So the same, if you look at this, the same y-axis scale remains consistent across the three different rows. The other thing that we should watch out for is that we must use different scales, that if we must use different scales, which is rarely advisable, that it has to be explicitly explained in the caption so the reader isn't fooled. Let's say for whatever reason, we are going to have a different scale on the top row, instead of going from 0 to 200, we're going to go from 0 to 400 because there were just so many more that survived that were on first class. So then we have to really make a very long scale, but that's different from the second and third classes. Then that needs to be included in the caption and like a big warning, right? Like, please watch out for this. The other thing is that the panel ordering matters. The arrangement of panels should be meaningful or logical. So you can go chronological order, magnitude, alphabet order, etc. So in this case, for example, died and survived, it doesn't really matter that much. But first, second, and third, that does make sense. You're not going to have first, third, and second. You kind of have to go in that order. So that again, you are helping your reader sort of like go with your story and understand it. Sometimes, and this is not the whole size of the graph because I had to cut it. I had to cut a few years above here. But what we have here is like many more panels. And we have, what we're doing is arranging them by year. And this is going to be movie rankings versus number of votes for movies from 1906 to 2005. So essentially, these dots are representing individual movies, and the lines just represent a linear regression of the average ranking of each one of those movies versus the number of votes that the movie received. In case of if they were, favorable or not favorable, if people liked them or not liked them, etc. So essentially here, because it's such a big, because I don't even remember where it started, but it could have been from 1900 or something like that, maybe even before. Anyway, so we have here from 1916 all the way up to 2005. So we sliced it like that, so it would have more clarity for the reader instead of just having that differentiated, for example, all the different lines by year, by color. It would have been such a mess. So then it makes it more clear. Obviously, all the different dots here and all the different scatter plots, it's just not as clear to see because they're so tiny. But again, it depends on what the story that you want to convey is. Because if you're interested in that, then maybe you can have all of this little panels here and then add a big one for like 2005, or let's say this is 2025, so the year before, 2024. So that could be another way to just have like the previous years, but you want to really showcase the recent movies, the average rating on recent movies, then you put it like in a big panel right here in order to convey more information. So it depends really on what information you wanna convey. Essentially here, what you see is that in recent years, it's like there's like a trend that it was going, your regression line had like a positive slope, and then little by little, as time goes by, it starts to go to a zero slope. So it starts to just go flat like this, so no change. So that there's no difference in the number of votes, all the way up to a negative slope in 2005. So I guess that's like the main takeaway from this one. But anyway, we have another bad example of this, which is we're seeing how to organize information in panels, right? So this is a bad example. Let's see why. So here we have bachelor degrees that are conferred by US institutions of higher learning, and we have the proportion of degrees on the y-axis across years. So we have them organized in panels depending on if they are business, social sciences or history, education, right? Like which group of, what would you call that topic? Science you're represented here. This is a bad example because if you see here, the y-axis is not consistent, not even by row, which you could change it, I guess, from top row to bottom row, but at least make it consistent for each one of these rows. Because this one goes from, let's say, this is going to be like maybe 5% all the way up to 25. But this one doesn't. This one may be going from 5 to all the way up to 18. This one is going from 5 to like 20. Like there's no consistency. So what that means is that this first line represents 15% for business, but this same line that you have here does not represent 15%. That one represents 10%. And then for education, that one would, there's not even the same line, guideline, right? And then that one would represent like 7%. So there's no consistency there. That is bad. The other thing that could happen is that some people, let's say for whatever reason, um, engineering, they started in 1980. They didn't offer any degrees on engineering before 1980. And then people would start this graph in 1980 instead of 1970, like all the other ones started. So that would also be like a bad thing to have here. Like you don't have consistency across your axis scales. So that's really bad. This is the corrected version of that, and you can see that there's consistency across all the y-axes. And in reality, if you do this, I would even go a little further and say, you don't really need to write down these 0, 5, 10, 15, 20% here and then here too. You can eliminate these y-axis on this third column and the second column because you already have it on the first column. So then you're cluttering your graph. You're not cluttering your graph. You're actually removing clutter by removing those repeated y-axes because it's redundant, right? Like you really don't need it. If you already know that this line is going to represent 5% across, you don't have to say 5, 5, 5. Like that's already there. So that's another way of doing that. And you could also even add that the years could also be eliminated, or you can leave them. It depends, right? Like if you think that you can actually get away with it and your graph is still clear, then you can even do that, right? Like just have them on the bottom axis, on the bottom um, row of your grid, and then eliminate it on the second and on the third row, or first and second, however you see that. Which is a little tricky to do in R, but I've done it and it's possible. You have to use other packages. ggplot doesn't allow you to do that. You have to use other auxiliary packages, but I've done it, so it's possible. It's a little cumbersome, but it can be done. And then let's talk about compound figures. So we saw examples of how to design graphs that are going to be one data set arranged in multi-panels. Now let's talk about how to have a compound figure, which is going to be different panels, yes, but each panel is going to represent a different graph. So like we said, we can take individual plots and arrange them in rows, columns, or other more complex arrangements and call the entire arrangement one figure that conveys or that it's going to convey one overarching point or that has one same theme. In this case, each panel is representing different kinds of plots for different data sets, or it could be, like I said, one data set, but you're just representing different information from that one. Each panel may show different kinds of plots or different data sets, but they're assembled in a way that it's one single figure. So this is very common to see in scientific publications, for example. And what we have is that you have figure one, let's say that this one is figure one, but then what you do is you label each panel with lower capital, is that how you say it? Well, anyway, with lowercase, not lower capital, lowercase letter. In this case, we go with I don't know how you call this alphabet, but the alphabet that we use in English. So you do lowercase, that's the only thing. That way you can refer to figure one. Well, in this case, it's going to be figure 21.5A. and then you add that to your caption, and then 21.5b, and then you add that in your caption. Okay, so in this case, you have the same thing, the same information, the trends in bachelor's degrees conferred by US institutions from 1970. You have here all the degrees combined from 1970 all the way up to 2015. And then you have it classified on panel B by each one of the different categories, if it was business, psychology, education, etc. Okay, so another thing to take into account is when you have these compound figures, how does labeling work? Or what should we watch out for when we're labeling compound figures? So in this case, labeling design matters. This is super important because the labels should be unobtrusive and consistent in style, font size, etc., across all the figures, and it has to be integrated into the design. So that means that you have to use the same font size for your x-axis. If you see here, female and male for panel A has the same font size as and even font type as the one that you have on panel B. Panels must share a consistent visual language, which means the same color scheme, the same symbol mappings, the same order of categories, etc. So by that, what I mean is that if in this case, if you see here, this is a bad figure because you have females here coded in, let's say this is pink or red, and males is in blue, but you don't have that in this other figure in panel A, where you have females and males both in blue. And then on top of that, or well, on the bottom of that, you also have males and females on the bottom graph coded in green male and blue female. So there's no consistency in the use of color across the different panels. That is terrible because then you're not making it easy for your readers to sort of understand the message that you're trying to convey. So by that, we mean use the same color. And the other thing is if you're gonna use, let's say females are circles and males are gonna be squares, and you're gonna have different panels that are gonna be scatter plots, use the same aesthetics on all of them. Okay. Consistency across panels. So talking more about this is maintain a consistent ordering. So if you have females always on the left and males on the right, keep it like that. You actually can see that here. Female is here on the left, and you keep that consistency on the scatter plot where females are on the left of the legend and males are on the right. All your axes, grid lines, margins, panel sizes, etc., need to align well across all panels. Misalignment makes the composite feel messy and can confuse comparisons. So what that means is that if this is like your x-axis, where it, like the bottom of it, where you start on panel A, panel B, which is right next to it, needs to have exactly that same line as the x-axis too, as the bottom axis, as the bottom line. That is, it doesn't necessarily mean that if you have here just like 4 different lines, that your panel B has to have also 4 different guiding lines. No, you can have more or less, but it just means that if that's the base, then keep it together with both of them, or keep it consistent between both of them. Because the bad graph would be like to have this B panel be like all the way up to here, and then you have like a big white space here, and then you begin your C panel. Like all of that, like mismatching thing, that would be terrible. And then I think that's it. Yep, I think that's it. That's the last part of the chapter. Let me see if I can go back. Yes. And that covers it all, you guys. That's chapter 20 and 21.
Thanks so much.
I'm gonna find the thing that I told you about, like using like the line as a kind of like a lasso, and then putting the label inside the line. It's super cool. It's done in R. I'll put it in Slack I'm gonna go find it and put it in Slack. I think I even have a blog post about it or something. But anyway, and then that's it. I'll see you all next week. And remember that if there are any other chapters that you would like to lead and explain to us, then please go ahead and sign up. And then, yeah, have a nice rest of your week, you guys.
Gabby, this
Thank you so
question
much,
might be
Gabby.
kind of premature, but
Yeah.
where to go after this book? Um, I was kind of briefly scanning like what other books there are on DataViz. It seems like, unfortunately, it seems like lots of the well-regarded books are paid, not open source. That's not to say the ones that are open source aren't good. It's just they seem to cover different things. Um,
Yeah.
yeah, I don't know. Like,
Oh,
just
do you want
curious.
to?
Had you done the
Yeah.
ggplot2 book? Is that worth doing?
Yeah. So we did it, I think last year or last semester. And well, we even had like a little discussion with the author. I forgot his name right now, and he's oh my God, my idol, but I
Hadley
just forgot
Wickham?
his name. No, not Hadley.
Oh,
We
Thomas?
had a with Thomas Pedersen, I think his
Yes.
last name is Pedersen, with him, and it was super cool. I think it's probably even on YouTube somewhere. He even gave us like his what do you call it? Like his take on AI and how that is taking over the whole data science community, etc. Super interesting and super insightful. But I'm gonna be honest with you. We are waiting on the new edition, which God only knows when it's gonna come out because he says that he's working on other projects right now. He keeps working on ggplot, and ggplot keeps getting better and better and better with all the updates. But the book is not really good. I'm gonna be honest with you. It's messy. We can read it again if you want, but it's once you read one of the chapters, you're like, what? Some of them were like, what do they want to say here? We don't understand the message that they are conveying here. It felt like a mismatch of things put together. There's another book that I just found out about data visualization too. So the author's name is Nicola Rennie. The only thing is I am not sure if it's free or not. That's the only thing. So I'm trying to find out about that. And then if you want, I can put it on the Slack channel. If you guys want to stick with data visualization, we can look for other books that have that.
Interesting. Thanks for the tip on the ggplot2 book. I've dipped into it in the past when I was trying to do a internal theme package. It was
Mhm.
kind of useful, but also yeah, it was useful, but I found myself, I think, looking more at examples in the wild to figure out how that works.
Yeah.
Which is fine. I mean, books are not going to give you absolutely everything that you want. Yeah, it felt like the book was more a book for would-be ggplot2 developers. Let's put it that way.
Yeah.
Yeah.
The other thing that we can do is go through the ggplot documentation. We can also do that because there are other book chapters that have done that in the past, other book cohorts, and we just go through the documentation. This Nicola Rennie book, let me do some digging into it and see if it's, but first of all, if it's free, and second of all, if it's worth checking out, because if it's not free, John is not gonna let us read it. And there have to be other books on data visualization that, yeah, maybe we can get something out of that.
Looks to
Or
be free. I think I've just found it. I don't know if this is the one, but
oh, it could be because it is on the, oh, yeah, 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 exactly. Yes, this is the book. And is it free? Yes, it is. Okay, well,
yeah, I think the way they
we
do
can
it is
read
like
this
with
one.
the publishers, like CRC seems to be really good about allowing authors to publish stuff in the public domain, and then they also do the print editions. But I guess it's a lot to do with like their publishing contracts.
Yeah. So yeah, so if we have access to some of it, then we can go ahead and read that one later. I mean, after this book. Nicola is very active on Blue Sky. She's super nice. She's even very active here on Slack on certain channels. She has replied to some of my comments and questions. We could ask her if we read her book, which would be the cohort one, again, like this one. I am pretty sure that we can coax her and convince her to have like a little discussion like this with us at the end of the book or at the beginning. I mean, I don't know. Maybe we can ask her. I kind of wanted John to approach Klaus Wilke too and see if we can have like a I don't know, like an hour, 1 hour session with him and then just like pick his brain. And then a long time has passed since the book ended, since he wrote the book. So like if he had to redo the book, like what are what are his ideas about that? Like would he do something differently? I don't know, just pick his brain or something. But I've been meaning to write John about that, and because he's also very active on Blue Sky, so I'm pretty sure he's very approachable. But who knows, right? Like I'm not making any promises. So I think those could be like our next little projects. Like try to see if Klaus Wilke wants to do a session here with us, and then see if John accepts us to read Nicola Rennie's book and then see if Nicola wants to do again like a pick your brain kind of session with her. Would that be okay? Is this something that you would be interested in?
Yeah, I think I'm gonna want to look over the Nicola Rennie book in a little bit more detail, but on quick pass, it looks interesting. Um,
Okay.
I can't really tell. It almost seems like it's a collection of use of sort of like walk of worked examples, if you will, which is quite nice, and it looks hopefully. I mean, this may just feel like confirmation bias. I really like how she sketches things out by hand before she makes the plots. I find that to be
Yeah.
useful because reading ggplot2 documentation, at least for me, I'm not as adept with it as I would like to be. It always seems like a black hole for time. And I can sink lots of time into things and maybe not advance so much in doing what I want to do. But that's maybe more of a skill issue on my end.
No, yeah, and I think that that's what happened with us. We had so many expectations with the Gigiblood book, and then we were like, "What the hell is this chapter about?" Like really, like that. You can actually go and see the recordings. Because, yeah, we just had no idea what that chapter was about. But we did, it was kind of like a large, not large cohort like the one that John has right now, but it was, there were several of us. I want to say like maybe 7, 8 people or something like that. And none of us understood some of the chapters. Like he's giving a lot of information, but there's not like a central theme around it. We got lost a little bit. So I would say read it once you are a super pro in using ggplot, and then because we learned a bunch of tricks. It's really really cool like that. I mean, I'm not saying the book is bad, it's just that you have to really dig in through like the weeds. I don't know if that's the right term to say, but you really have to like weed it out, and then you find the gem, and then you keep weeding things out, and then oh my God, another flower here. Like let's yeah. So it's right.
Yeah.
It takes a long time.
Kind of feels like
Yeah.
that this book a little bit. I mean, I think you put it nicely that I mean, none of the content is bad. It just seems like it's maybe more of an introductory book, but there's some really cool ways of tackling the problem that I never ever would have in a million years considered. And those are like the one today about the having the
Mhm.
coloring the axis, instead of using a separate label. That's brilliant. I hope it can be done in R.
Yeah. You
But
have to like
that was simply brilliant.
yeah, so it's but at least this book is organized and it's clear and the chapters are short. The ggplot book, the chapters are long. And yeah, it's messy. It's messy, so it's frustrating sometimes. It's worth it, but I wouldn't recommend it if you're a beginner because you'll get confused. I think that if you're a more seasoned person, you already know how to use ggplot, you just want to learn a few more tricks and become like a pro, but you're already good, then read it. Then read the book. That would be at least my take. I don't know what the others in that cohort think, but yeah, that's my take at least.
I'll have to go
So
and look at some of the videos on YouTube, and then also look at the book myself. Like I said, I think I dipped in for the theme package or the theme part because I was trying to figure out how to do a theme package. And it's sort of it didn't quite meet my expectations, but maybe my expectations also weren't reasonable. And in the end, like I said, I found it more useful to look at what others had done. And interestingly, like, I looked at a few examples online and I didn't see any consistent approach to doing ggplot2 theme packages. So that was also interesting, which made me feel a little bit better about the book in the sense like
yeah.
no one it doesn't seem like it's a solved problem in the sense people can do it, but maybe not solved in the sense that there's a you know three-step algorithm for doing it.
Yeah. So I think that yeah, let's do that for next week. Let's go over the book and then let's see. And I'm gonna put it on the Slack channel too in case others that didn't join us today are also interested in that. And let's sort of like evaluate if this is a good book to continue. And then yeah, maybe that could be like where we go from here. If not, I'll keep an eye out for other data visualization books that we might encounter. Um, and yeah, Vanessa,
Yeah.
do you have
I should
anything you
probably
want
also
to?
just invest my time in the Tidy Tuesday stuff because like one thing that I'm in another book club simultaneously right now, and I would say DevOps for data science.
Oh yeah, yeah, yeah.
Extremely great book, or at least for me. It's catching me at a good point. But like the one thing that's really nice about the book is that each chapter has an associated lab. I've not done the labs yet, but also it's kind of nice that someone gives you bite-sized projects that help you learn the thing, reflect in a practical way on the things that are in the chapter. I mean, obviously you could come to a book and do that with whatever content is there, but it's helpful for busy professionals when someone has already kind of
Yeah.
done a little bit of that legwork for you. Yeah. And I've not
Yeah,
seen that connecting it to DataViz. I've not seen that in the DataViz sphere
yeah,
yet. Yeah.
you're right, you're right. And with Tidy Tuesday, I've always said that we need like a book club, but not a book club, but like a meeting where we say, like, let's say Thursdays at 2, where we all work on a same Tidy Tuesday, and then we just share what we did in 1 hour or something, and then that's our contribution. Because I feel like if we have this organized based and then the pressure of others doing the same thing, and we're like, oh my God, we're motivated, right? Like, and then you can sort of like see how others are organized in their Tidy Tuesday. I feel like that could be like a good motivator. But yeah, Tidy
That's a
Tuesday,
neat
I
idea.
think,
John's got, I think, this other thing, what is called like the project club, where, as I
oh,
understand it, people present their projects. It's not at all the same thing, but maybe it's kind of an adjacent idea.
yeah,
Because it
yeah,
would be nice too to like hear how people reason through their plots and glean some tips and tricks on how they approached it. Because there's this giant and growing ecosystem around ggplot2 stuff, and I'm not in it often enough to really know what's what out there.
yeah,
And
yeah.
sometimes you can find a package that has a function that solves exactly your problem instead of you having to roll your own. And that's always great.
Yes, exactly. I feel like it's grown so much, but it's super cool. And everything that you keep learning, it just adds more. And it's, oh my God, I love it. Data visualization for me is like crack. I love it. I can't get enough. And it's like, it's so cool every time someone does something that I haven't even thought about, or the same thing that I wanted to do. Like, let's say we're both doing like a line plot, but each person is going to do it differently, but it's the same, it's the same data, it's a line plot, but each one has it organized differently. I love it. But yeah, I'll pitch my idea to John and see what he thinks about. And I'll see if someone already started looking at this book, and maybe there's another cohort for the Nicola Rennie book too. But yeah, let's meet again next week and see if everybody is on board with this book or not. And and yeah, let's that way we can continue with the data visualization conversations.
Thanks so much for presenting, Gabby.
No, of course, my pleasure. Thank you guys for being here. Vanetta, if you want anything you want to add or say something?
No, I'd really like to also check Nicole's book. I've been
Mm.
following her and her work for the Title Tuesday, and it's really cool.
Right? Okay, perfect. Then yeah, let's hope it's a good one. All right, you guys have a happy weekend, and we will see each other next week.